All right, everybody. You should have gotten an email from me yesterday with this snip in it, and you should see this in your ClickUp now in your math folder. So this is the module on polynomials and rationals. You'll notice that a couple of these episodes are from today, or due today, rather, and that's because we spent quite some time with these in our synchronous meetings, and then asynchronous assignments were given from from the slides. So this is where you can then begin to record that. So you'll notice that this first card has complete the following investigation. It's on Desmos. That should be way done regarding complex numbers. And then we've got a few videos that we talked about in class. So if you wanted to revisit those to post a comment, that'd be great. And then episode 2, polynomial functions and their graphs. I did put in some resources up here. There's quite a few Desmos activities because we spent the bulk of our time really exploring these concepts. But first one was about quadratics, a review on quadratics. And then a lot of these visuals are a review from what we talked about in class: end behavior, real zeros, intermediate value theorem, and then another Desmos. So make sure you do that, click that. Guidelines for graphing polynomial functions. We did that in class. We talked about multiplicity, and then we had 2 concluding Desmos investigations. So make sure you go through that checklist and post anything in there that you need to. So, which brings me to what we started talking about on Monday, which is dividing polynomials. We didn't actually dig way into it, but this is what I want to talk about today. So the things that are in the slides, but also I've put here, just kind of a review on what long division looks like. And so we'll go through this example in just a moment. But these terms, so you've got the divisor and the dividend. The divisor is how many pieces we're breaking something into. The dividend is how many total pieces we start with. And then the quotient is how many whole pieces can we get in the end. And then the remainder is the value that we're left with that does not get put into the whole. And that occurs when we're dividing polynomials. These expressions that have unknown values in them. So you'll notice that I started up here with resources, and then I decided to actually embed all the resources below, so you don't even need that. So polynomial division, synthetic division. I'm going to go through a couple examples of those today. So then here's the example, one example that I'm going to talk about today, with the solution, the steps that happen. And then remainder and factor theorems. I don't know why this is there. So this gives you a theorem, and then it tells you the proof of that theorem. Little thing here, and then another example. We actually might talk about this. So I'm going to copy this. Factor theorem, and then lastly, a couple of tasks, the NASA task, and then an impossible division task. So those are the things that you're going to be concluding with. Apparently I can't type. So if this was done by Monday, that would be excellent. Really just kind of watching these resources and then completing these last 2 tasks, whatever mode you want to do that in, polynomial division or synthetic division. So, and then the rest of this, so real zeros of polynomials, we're going to take a look at on Monday. Complex zeros, we're going to take a look at on Wednesday. And then that following Monday, we'll start exploring rational functions. All right. So let's take a look at a few of the examples that are actually drawn from our slides. I wanted to explore these last week with you, but we just ran out of time. And actually, before we dig in, I'm going to move this down because I actually want to talk about the process of division as a general idea. So in the slides, in ClickUp, we saw something that looked like this, 38 over 7. Maybe if I can draw it right, 38 over 7. And what this means is that it's the same thing as 38 divided by 7. So this is the same as 38 divided by 7. And so if we think back to elementary land, we can actually do long division with this, right? So I can take 38 and divide it by 7. And so what I do with something like this is I start off with how many times does 7 go into the 10 to the tens place? So how many times does 7 go into 3? And I say, well, it doesn't, right? 7 cannot go into 3. So there's nothing that's going to go in my tens place right here. But then I take a look at the whole this whole number right here, and I say, well, 7 times 5 is 35, and 7 times 6 is 42. So I know that it has to be there's only an even amount up to 5 that goes into 38. So we know that it's 5. And so once we know that that's 5, we come back here and we multiply by 7, and then we put that value right here underneath 38. And then since we have divided that out, we're going to subtract that from our original value. And we're left with 3. 38 minus 35 gives us 3. And since we're left with 3, we call that our remainder because we already know 7 cannot go into 3. If we wanted to go into decimals, we could, but we have 3 that's left that's being divided by 7. So the way that it's written is our quotient is 5 and our remainder is 3. So you might remember something like this as a kid where you wrote 5R3. Where that R means remainder. But as mathematicians, as experienced mathematicians, we know that this 3 is out of a 7 here because 38 is being divided by 7. So what's happening up here is 38 over 7. We are splitting that into 35 over 7 plus 3 over 7, right? So 35 plus 3 gives us 38. And so then we are then consolidating this into a whole number, which gives us 5 plus 3/7. And so this is what we're trying to do when we do polynomial division. We're trying to do the exact same thing. When you have a larger degree polynomial and we divide it by a smaller degree polynomial, what happens? And if we have a remainder, how do we write that? Okay, so that's what we're going to start with. So right here with slide 57, I pulled the problem in, and it looks like we have a quadratic that's being divided by a linear expression. So I'm going to write this out. And I have 6x squared plus 26x plus 12. And then we do long division the same way that we do with numbers. So what I need to figure out is how many times does x divide into 6x squared? And I need to multiply it by 6x, right? So x times 6x gets me 6x squared. So that's going to be the first value that's in my quotient. And I'm going to put it in the x place. And so once I have that, I now need to multiply that by both terms and subtract those out from my polynomial. So I get 6x squared, and then I get minus 4 times 6x, so minus 24x. And I'm going to subtract that out, and I get 0. I get a negative negative means that this is actually positive 24, so I get 50x. I'm going to bring this value down, and I get 12. All right, so now I need to do the same thing with this new expression down here. So let's go with a different color. So how many times does x go into 50x? Well, I'd multiply by 50, right? So I'm going to add 50. And then we're going to come back because we need to subtract that from our expression. So I have 50x, which is what we want. And then I have minus 50 times minus 4 times 50, so 200. And I want to subtract that. And I'm left with, well, those go away because they're opposites. And then a minus 200 means I have 212. That's a constant term, so I can't take a linear expression and divide it into a constant term. So I'm going to be left with a remainder of 212. Okay, so what we see here is that if I take 6x squared plus 26x plus 12, and I divide it by x minus 4, I'm going to get the quotient 6x plus 50, and then I'm going to get a remainder of 212 over x minus 4. And so what we've done by doing this division is we've demonstrated that these two are equal. And so we can check this looking at the graphs to make sure that we did our division properly. So I'm going to go to a Desmos, and if I go here, so and I'll send these to you, but I'm going to turn that on. So this is the actual division, and then if you notice, let's scooch it in. Whoops. Let's zoom out and then let's scooch it in. Instead of being so far out. About 50 and 50. All right, so then we get this. So we want to see if our quotient plus remainder lands on top of this, because if it does, then that means that we have done our division properly. Plus 212 over x minus 4. Okay, sweet. So we know that those two are the same. Those are the same functions. All right. So let's go back to here and let's take a look at this next example. So this is another example, except this time we're looking at a fourth degree polynomial being divided by a second degree polynomial. And then in the end it says, find the polynomials whoops, where did it go? And the polynomials q of x, r of x, such that this is true. And this is the division algorithm. You guys, this is what we were just talking about. And so we're going to go through this, and then I'm going to talk about how this shakes out. All right, so let's start dividing this. So I have p of x divided by d of x. Being divided by 2x squared minus x plus 2. Okay, so we need to figure out how many of these first terms go into this first term, because that's what we're doing. We're dividing, right? So if I look at the coefficient first, 2 times what number gives us 8? I'm hoping we see that that's 4. And we need to think about how many x's more do I need to get from x squared to x to the fourth. So 2, 3, 4. So I need this to be squared. So x squared times x squared gives me x to the fourth. So let's put that in our squared category. And then we want to multiply that through each of these terms. So I'm going to get 8x to the fourth. And then, interestingly, I'm going to get minus 4x cubed. You'll notice that our x cubed term isn't up in our original polynomial because we must have a coefficient of 0. So let's write that in just so that we don't get tripped up. Hopefully I don't screw up this problem by trying to move these to the side. Okay, so let's write that in as, I'll write it in pink. Plus 0x to the third. Okay, and then coming back here, 4x squared times 2, 8x squared. So plus 8x squared. And I want to subtract that from my original because this is division. Okay, so these are opposites. 0 minus a negative 4x cubed gives me 4x cubed. 6 minus 8 gives me minus 2x squared. I'm going to bring down a minus 3x. All right, and then we're going to do we're going to do the same thing now that we have, we're going to divide 2x squared and see how many times to get 4x cubed. So let's look at the coefficients first. We need to multiply by 2. And we need to go from x squared to x cubed, so we need to multiply by 1x. So 2 and x. So plus 2x, and then we need to take that and we need to multiply it here, here, and here. So let's do that. 4x cubed, that's what we want, minus 2x squared. 2x times 2 is plus 4x. So then let's subtract these things. We're going to scroll down a little bit. These are opposites. Negative 2x squared minus a negative 2x squared. So those would be opposites. Convenient. Minus 3x minus 4x. We get minus 7x. And then we're going to bring down 1. All right, so then here, it might not seem like we are done, but we are, because if you look at, there's nothing that I can multiply the divisor by to get me to this new dividend. Okay, so I can't multiply 2x squared by an x value. So at this point, we're finished with this division. And so then it asks us to write it and look like this, right? So we know that q of x is our quotient, and that's what's on top here. That's right here. Okay, so 4x squared plus 2x. And then we know that Rx is what our remainder is. Okay, so we can write out the division algorithm. Let me give me a little bit more. Let me give it a little bit more space. So we can write out the division algorithm. So the division algorithm being p of x. So 8x to the fourth plus 6x squared minus 3x plus 1. And then we're setting that equal to d of x, the divisor, I'm going to run out of space, but that's okay. 2x squared minus x plus 2 times the quotient, add the remainder. All right, so with that finished, we can actually go back to Desmos, take a look at this. So let's do that. Let's turn these off for a second, and let's just make sure that everything shakes out. So we have our original function, 8x to the 4th plus 6x squared minus 3x plus 1, all divided by 2x squared minus x plus 2. All right, and then kind of looks like a parabola. So let's then write out the other part of the division algorithm, d of x times q of x plus r of x. So I'm gonna get all my places set up, and then these should land on top of each other if we did our division correctly. 2x squared minus x plus 2, 4x squared plus 2x, and our remainder, negative 7x plus 1. Ooh, let's see that I typed everything properly. Oh, silly. If we're using our division algorithm, this shouldn't be there. There we go. So our division algorithm says our polynomial is equal to the divisor times the quotient plus the remainder. All right, so with that, these two should be the same, and that's what we see. Sorry about that. Excellent. All right, let's talk synthetic division, and then we'll wrap up. So synthetic division is a process where you can do polynomial division quickly, as long as your polynomial is being divided by a linear expression, meaning something in the form of must be divided, or I guess your divisor must be divisor. Math teacher can spell. That's in the form x minus c. So in this specific circumstance, we see that, right? Like this is x minus 3, so our c value is 3 for this specific example. And we've got this cubic polynomial, 2x cubed minus 7x squared plus 5. So to use synthetic division, you kind of write it a little bit differently. Okay, so what you do is we've got this bracket up here, and you put your divisor over here, you put your c value right there. Okay, and then the other way that you do this is you write the coefficients of all of your polynomial terms. Okay, so we have a cubic term, we have a second degree term. You'll notice that we don't have x, so we'll just call that 0x and 0. And then we have our constant term. Okay, so this is how we set this up. And then the process for going through this is we bring this value down and we get 2. And then what happens is you multiply 3 by 2, and that value goes here. And then what happens is you add down the columns. So we're going to add. So we multiply here, you add here, and then you get negative 7 plus 6 gives me negative 1. And then it's going to happen again. So I'm going to take 3. Let's go like this, a different color. I'm going to multiply it by negative 1. and that's going to give me my value right here, so negative 3. I'm going to add 0 and negative 3, negative 3, and then I'm going to take my divisor. Remember, this represents x minus 3, and I'm going to take that and I'm going to multiply it here, and I'm going to put that here, so negative 9, and then I'm going to add down, and I get minus 4. And since we have no more to go in this process, this is our remainder. So we'll go yellow is the remainder. And then these collection of numbers are our quotient. And so what that means for us is because we are dividing a cubic by a linear, we're going to be left with a quadratic. So a third degree divided by a first degree leaves you with a second degree. And so the way that we would write that out is there's two different ways that we can write this out. So we can start with 2x cubed minus 7x squared plus 5 divided by x minus 3 is equal to 2x squared minus x minus 3, because this is our second degree, this is our first degree, and this is our constant term. And so we see those right here, and right here, plus our remainder, so plus minus 4 over x minus 3. Okay, so that's one way we can write it, as the quotient plus the remainder. But we can also use the division algorithm and say that our polynomial that we started with is equal to our divisor times our quotient plus our remainder. So two different ways to write the same thing. And I think there's a few videos more on synthetic division. So I'm going to close out and please see those. Oh, just kidding. Actually want to do the graph. I want to verify. All right. So let's verify that we are correct. So 2x cubed minus 7x squared plus 5. This should look like a cubic, and it sure does. Let's zoom in a little bit. All right. Maybe we squish it in to like. All right. So that looks like a pretty classic cubic function. So then let's do our divisor times our quotient and minus 4. Sweet. Another way, here I go getting talking. I guess we've already been here for a while. But another way to check this, you guys, is if you go through this division, you can just multiply these out and make sure that you get back to your original polynomial. And by doing that, you just FOIL, which is something from way back when. But I can multiply this all the way through. So I get 2x cubed minus x squared minus 3x. And then I can multiply through here, all three terms, and I get minus 6x squared plus 3x plus 9. And then we have our minus 4, right? So if you FOIL all of that, and then let's check it, and we'll check it in pink. So this is our only cubed term, so 2x cubed. We have minus 1, minus 6, so altogether we have minus 7. These cancel because they're opposite, and this leaves us with 5. So we've done our division correctly once we go back and FOIL that. and we checked with a graph. All right, we're done. Hopefully that gives you a good jump start on dividing polynomials.